Okay guys, I'm not going to be here this afternoon, or maybe if you are gone, I wanted to go through this with you just so that you can have a good idea of how ionic compounds form. This is a little activity that kind of helps you visualize and see how they fit together as a puzzle might. So I want to go through the instructions with you and do a couple with you so that you can complete this hopefully as much on your own as possible. So looking at the top, these are ionic compounds. Remember, an ion is a charged atom or particle. So it'll either have a plus or a minus charge. And so to form those compounds, the positives attract to the negatives. These are also going to include polyatomic ions. Poly means many. So things with multiple atoms, atomic is atoms, and so polyatomic ions are those that have multiple atoms inside the ion. And so you're going to get these puzzle pieces, this for one. So here you have, this is one ion, it's got phosphorus and oxygen. And so because there are multiple different atoms, this would be one of those polyatomic ions. It's got a charge of 3 minus. And so you won't know these. I don't expect you to know these. So I gave you a list. On my desk, if you don't have it, this periodic table with all this stuff on the top has all the regular periodic table stuff. But on the back are these two lists. And so this first one is organized by the name of these ions. The second one is organized by the formula. And so this one that I just showed you, PO4, you would go find PO4 down here and notice PO4 3 minus, that's the same thing. This one is called phosphate. Most of these on this list will end in ate, ATE, or ite, ITE. There are a few that end in ide. And so you got to be careful, because usually this ending in "ide" means it's just an element, like oxide or nitride. But this one, OH, happens to end in IDE as well. So you need to kind of be careful as you go through these. But that list, this list is what's going to help you through this. This is all the polyatomic ions you'll see. The only one that's positive is this NH4 with a +1. It's called ammonium. And so you'll need that one. This is on this activity. So if you see ammonium or you see NH4 with a plus, that's going to be a cation that's a polyatomic ion. All the rest of these are negative. That one is the only positive. And so what you're going to do, go through here, and as you read along, you're just going to circle these that have options. Ions, which are charged particles, can be either positive or negative. Positive ions, those are cat ions. I remember this because the T is like a plus sign. Or you can remember that cats have paws, they are positive. And in order to get a positive charge, you have to lose electrons. So when you lose electrons, there's more protons, therefore it's going to be positive. They're going to be represented by cards that have indents. And so here is an example of these cards that this one is positive. It's got a 3+ charge. And so these indentions are what's going to tell you that it's a positive charge. Here's one that just has a 1 + 1 charge, and it's going to have a little indentation. And so the positives will be indented in like this. Moving on, each indent represents a respective quantity of electrons. So that copper one had 3 indents because it had 3 for its charge. The negative ions, so cations were positive, negative ones are anions, and they have gained electrons. And so these will have kind of the opposite. These are going to have points. And so here's NO3, that's one of those polyatomics. It's got a 1 minus charge, so it's got 1 point. PO4 has a 3 minus charge, so it has 3 points. And so you will fit these together like little puzzle pieces. Here's copper, this is a +2, so it's got 2 indents, and so they would fit together like that. And your goal is to make a rectangle. And so see, obviously this one is not a complete rectangle. This one wouldn't be a complete rectangle either. So the idea is to use multiple of these positive or negative ions to complete your full rectangle. So the number of points represents a quantity. You're going to piece these together. And so here is this first one. It's going to give you the names, and then you're going to draw in the puzzle pieces that you create and put together, and then the ratio of these followed by the compound. So I'm going to show you how this first one should go. Okay, so aluminum oxide. So I'm going to go find aluminum, Al. It's got a 3+ charge. And then oxide. Ending in "ide" usually indicates that it's just that one element, so oxygen. If it ends like this one is in 8, it's going to be a polyatomic. So you have to go figure out on that back list what carbonate is. And so starting with aluminum oxide, we have aluminum, and then oxide refers to oxygen. And so if I put these together, it doesn't make a full puzzle piece, or a full rectangle, excuse me. And so I would have to add more. If I add another oxygen, I still don't have a complete regular rectangle, so I'd need an additional aluminum. Rectangle still not complete. But if I add one more oxygen, now I have the complete rectangle. And so what I'm going to do now is transfer this drawing onto my sheet of paper. This one happens to be done for you. It's the example. But you have 2 aluminums and 3 oxygens. And so that ratio, however many of each there are, is what goes on this part. There's 2 aluminums. The 2 goes there. There's 3 oxygens. The 3 goes there. And so these little ratio numbers become subscripts in the formula. So you'll write whatever you have, aluminum, Al, with a little 2 below it, and then oxygen, O, with a little 3 below it. So this compound aluminum oxide takes 2 aluminums and 3 oxygens. The reason it takes those different amounts is because those charges have to balance. So you can't have an overload of one charge versus another. It's not going to be a complete and happy compound. And so if you add the charges, here I have 3 and 3, that gives me a 6+ for the positive, and each oxygen is 2 minus, so 2, 4, 6, 6 minus, those cancel out to be 0. And so that's how you can figure out how many you need. All right, for this next one, we're going across, we're going to do iron. These Roman numerals tell you which iron it is. Some metals specifically have multiple ions they can make. And so this little 2 tells you which one it is. And so if you go through your little bundle here, you're going to find 2 different puzzle pieces that have Fe for iron. And so one of them is 3+, the other is 2+. So which do you think iron 2 refers to? I'm guessing the 2+. And so that Roman numeral there tells you which iron ion it is. And so you're going to need this Fe2 and then nitrate, ATE. That's my polyatomic ion. So I've got to go to my periodic table. And this one on the left is alphabetically, so I go find nitrate, ATE. It is NO3 with a -1 charge. So I go in my little stack of goodies and I find the NO3 with a -1 charge. And so I try to assemble this puzzle, but that doesn't complete my rectangle. So in order to complete it, I need another one. And it doesn't give me another name there, so it's got to be another nitrate. So I go looking again, and lo and behold, there's an additional nitrate. And so now I have completed my rectangle. If I look at my charges, I have a 2+ here, and a 1- and another 1-, so 2- here, so +2 -2, that balances out. And so I'm going to redraw what I created here. Forgive my artistic ability, it is not good. Oop, let's go there, and then over here. Yeah. And so over here I've got the Fe2+. Here I'm going to have an NO3, 1-, and another NO3, 1-. So I'm going to have 2 of those. For my ratio, I count how many of each I have. For iron, I just have 1. For nitrate, I've got 2. So that's going to be my ratio. And then for the formula, I'm just going to use the symbols that are given there. I've got Fe, and there's only one of those. We don't write anything if there's just one. So we're just going to leave the Fe. And then I've got NO3. And I've got 2 of those. But if I write it like this looks like there's 32 oxygens, and that's not accurate. So think math, PEMDAS type stuff. I've got to keep that NO3 together because that polyatomic ion is bonded. It's not going to separate out. And so I use parentheses around the NO3 to indicate that that's the polyatomic ion. Those stay together. And then the 2 indicates that there's 2 of those ions. So I have 1 iron 2, 2 NO3s. FeNO3 is how we would say that formula. So that's kind of the basics of what we're going to do. Notice here's another one, copper 3. So you're going to be looking for copper with the 3 here. Nitride, IDE. This one is just going to be nitrogen, and I believe it's 3-. Okay. Another one to look out for. Down here you have magnesium hydroxide. This is one of those that it's a polyatomic even though it ends in IDE. This one is going to be OH with a -1 charge. This is what it looks like. And then another one to look out for, acetate, ATE. So if I go look at my polyatomic ion list, acetate is this first one here, and this one has 2 possibilities. If you take organic chemistry, you'll figure out why. It's 2 different ones, but you're going to look for one of those. The one we have in this one is this second one, or the puzzle piece here. And so for acetate, I can't pick it up. There we go. So this is the one that will be for acetate. CH3COO -1. Okay, so those are just a few things you need to kind of look for, be aware of. I recommend, this is just me and the way I like to do things, I like to have all of mine kind of in the same thing. So all of mine in this blue one are the -1 charge. All of these yellow ones for mine are the -2 charges. The orange ones are the -3 charges. My little pink ones are the +1, and then the +2s, and then the +3s. And so this is how I choose to kind of do that. You can figure out however you want to do it. Some people prefer to just spread them all out together. Whatever you want to do is fine, but just however you want to organize it. But the idea is to make those puzzle pieces fit together so that everything cancels out and you make a solid rectangle. If you've got an overlapping rectangle, then it didn't work. When you're done, turn this in and put all these back in the baggie. All of the ones on the back should have a number underlined. So these all go with group 10. So the little baggie you have should have group 10 on it. There should be 33 shapes. 33 shapes in each bag. So make sure when you're done you have 33 of those little pieces and you put them back in the bag. Let me know if you have any questions. You may finish today, you may not. I truly don't know. It kind of just depends. But there is another assignment that the sub will let you know about if time permits. Have a great day, guys.